In this assignment, we are looking at the data of a hypothetical experiment where we're testing the temperature effects of lipase. And so in this experiment, we have lipase digesting a fat and creating fatty acids and glycerol. And these solutions are in 5 different test tubes with different temperatures. And if we look at this data table, we see that it's not completely filled in. So that's one of the things that you need to do is fill this in with these temperature ranges here and whether or not milk was added. And you can tell whether or not milk was added by the changing concentrations in this table. So it asks you what the substrate is, what the product is. So that information is given up top. You'll have to figure out what the product is for explaining why conditions change, and think about what could be changed in this experiment to figure out if the student's data is good or how it could be better. Then we go to look at the optimum pH for amylase, and in this part of the assignment you have to pretend that you are designing this experiment. So what would you do if we were in class and able to actually carry this out? If I have starch and iodine together in a beaker, I will have a purpley black solution. And as time goes on, if I have that amylase in there, it will become a clear solution. So I'll just draw that so it looks like there's a liquid in there, but it's clear. So that is what you will be looking for in this experiment. It is a color change. So then, depending on what the pH is, we're told that we are investigating the hypothesis that the optimum pH of amylase is 7.5. And that seems reasonable because amylase is in saliva, and we don't taste our saliva as being either acidic or bitter, so it seems reasonable that it would be pretty neutral, that this enzyme would work best at. If I am testing that the optimum pH is 7.5, that is my independent variable. And my independent variable is always, what am I changing in an experiment to see what the outcome is? And the outcome is the dependent. And so if I am testing my pHs over a range, I will not be keeping that constant for this question. I saw that some students put pH in that, so make sure that if you are saying that you're varying a variable, you can't say that you're also keeping it constant. Another point that is important is if I am testing that the pH is 7.5, I should probably test the pH at 7.5. So that means that I can mix these pH buffers, because a buffer is just a solution that keeps the pH at a constant state. So I can mix these buffers to get whatever range I want. I could mix them to get 5, mix these two equally to get 5. I could have 5.5, whatever. And I don't need to know the calculations right now of how to make those solutions. I just want to know what solutions do I need to make. So make sure you say what range you will vary it. Not everybody, if we're testing 7.5, we might not need to. It might be good data. It's not terrible to test it at, to see how your curve looks for that enzyme activity. If it's like this at 2.5, then that's still good data to have. So I want to know, are you testing it over time? Or like how long will this occur? What are you looking for? How will you vary the pH? And what will you keep constant? And that's it for this assignment.